split phase dual voltage rectifier circuit. So we've got our transformer. Now I'm going, instead of drawing the diamond, I'm going to draw the bridge rectifier circuit similar to the way it is shown on page 13. And the way you do it is like this. After drawing the transformer, what you do is you draw your diodes, 4 diodes like this. 1, 2, 3, 4. Okay? So let's draw 4 diodes like this. This is a bridge rectifier circuit that we're drawing, whether we draw it as a diamond or whether we draw it vertically, one and the same. So after we draw the 4 diodes vertically like this, we do a connection to the transformer. So the first connection I do is at the top, and the second connection I do is to the second pair of diodes. Okay? And then I connect these 2 diodes at the top and these 2 diodes at the bottom. There's my bridge rectifier circuit, drawn a little different. Okay? So both are one and the same. Whether I show it as a diamond or I show, come on over here. All right. Now, if I want to talk about a split phase dual voltage rectifier circuit, what I have to do is work with a center tap transformer. So I'm going to bring a center tap lead out of the transformer. 1, 2, 3. So the middle lead of the transformer, I bring it out and I draw that guy all the way this way. Okay? And by doing this simple connection to the center tap of the transformer, what I end up with is a voltage output which is a positive voltage and a negative voltage. So let's explain how we do this. So this is all I do. Get a center tap, bring it out. Now I connect my load like this. R1, R2. And the voltage at the top, I'll call that V1, and the voltage at the bottom, I call V2, are going to be opposite in polarity. V1 will be positive, and V2 will be the same value, negative. Okay? So, dual voltage, which means plus and minus, and split phase. Okay, this is the circuit we're drawing on page 1 of note 8. So, I'll label the diodes randomly D1, D2, D3, D4. It doesn't matter how I label them, as long as I know how the circuit works. So let's look at the 2 cases. Let's take case 1, positive half of the sine wave. Case 1, positive half of the sine wave. What's going to happen when I do the positive half of the sine wave? I'm going to end up with a voltage at the secondary side, which is also going to be a sine wave, and then I'm going to split that up into two voltages. One voltage at the top, another voltage at the bottom, right? That's what a center tap does. Your voltage is split up into two. If this is 120 volts, and if it's a 10-to-1 ratio, then I will have 12 volts on the secondary, 6 at the top, 6 at the bottom, right? Nothing unusual or special about that. So, I'm talking about now the positive half, which means positive half here and positive half here. Is everybody with me? So with the positive half, the polarity is going to be plus, minus, at the split, right? Now let's look at the plus minus at the top. With the plus minus, current's going to flow out of the plus, into the diodes, into the load, and it'll come back to the minus. Let's see how it's going to do that. I start out at the plus, I go up D1, I go into R1, and I come back to the minus side. Okay? So that's going to be, I'm going to draw this, I'm going to have you draw the results on page 2. So everybody turn to page 2. And in the space, in the blank space that we have on page 2, I want you to draw first a sine wave, which is V secondary. First draw a V secondary at the top, nice and big, on page 2. Okay? Then, drop down some lines as best as you can so that we can identify what the voltage is going to do for the positive and for the negative. I have to draw two graphs. One graph at V1, the other one is V2. So, the first graph I'm going to draw is going to be V1, this guy here. So I'm going to draw a line here, put a 0 here, and label V1. And I'm going to draw another graph down below, 0, and I'll label that V2. Okay, because I have two outputs, a V1 and a V2.